Hi, we're Team Well True. Our team chose problem statement 1. It's our honor to introduce our product HARMONIA, which automatically evaluates review quality and relevancy for Google location reviews. For our project, we use a hierarchical pipeline that starts with a simple metadata-based filter to drop obvious noise such as empty text, duplicates, or spam, so later stages don't waste compute. We then run a fine-tuned FastBERT that outputs a validity probability with entropy-based confidence. High scores are auto-accepted, low scores auto-rejected, and only on certain cases are escalated. For those harder reviews, we invoke Qwen 8b as an LLM judge, and when a photo is present, apply keep to verify text-image consistency. Finally, HARMONIA fuses everything, applies the threshold set in the UI, and returns a single valid or invalid label with a brief reason. This diagram shows how we decide if a Google review is valid with clear reasons. We start with a light stage 1 filter, simple rules plus metadata checks such as GPS consistency. In stage 2, we create pseudo-labels on Google local data using GPT-4o, fine-tune FastBERT, and run inference. FastBERT gives a valid probability and confidence. With the upper and lower cutoff, only uncertain cases move on. Stage 3 escalates those hard cases to Qwen 8b. We support different adjudication models like zero-shot. We also embed reviews with business info and use Fast to retrieve the top 5 similar examples with GPT-4o labels. Here we plot accuracy against average processing time per review. The HARMONIA curve traces the speed-accuracy trade-off. Lower cutoffs run faster, higher cutoffs escalate more cases to Qwen and leave accuracy. The left square is FastBERT only, which is the fastest and the least accurate. The top right triangle is Qwen 8b only, the most accurate and the slowest. For any latency target, HARMONIA delivers the best or near best accuracy without wasting compute. Let us show you the live demo of HARMONIA. On the left, the control stare the pipeline. In stage 2, the FastBERT lower invalid threshold tells the system that any score below this value should be rejected immediately, while the FastBERT upper valid threshold marks any score above it as an automatic accept. Between those two cutoffs, reviews move to our education step. The third slider sets a clear similarity threshold. In stage 3, you pick the education model and choose how strict you want it to be. Zero shot for speed, few shot for more guidance, few shot plus chain of thought CoT to force step-by-step reasoning, or few shot plus CoT plus RAG when you want retrieval augmented accuracy. For single input, you can key in the information at hand, and HARMONIA will automatically extract the important fields like user ID, name, rating, etc. You can also upload a business photo so we can check visual text consistency. When you run the analysis, we show the top 3 reference matches for context, and then the final decision, valid or invalid, with a short reason such as irrelevant advertisement or ran no visit. For bulk processing, CSV Batch applies the same pipeline to a file of reviews and presents a quick dashboard, a donut for valid vs invalid, and a bar chart that breaks down invalid types. A detailed table lists each row with intermediate signals, and you can download the full CSV. If you prefer quick spot checks, screenshot analysis let you upload a Google review screenshot. We extract the text and return an immediate verdict using the same rules. Moving on to the fourth section of future work. To keep pushing accuracy without slowing the system, we're exploring 2 upgrades. First, listen reasoning. Instead of forcing the model to write out long chains of thought, we reuse its hidden states as compact thinking steps. That cuts inference overhead and lets the model reason a bit deeper on hard causes. This is useful when the signal is subtle, like borderline no-visit rants. Second, we're exploring UGCoT for multimodal reasoning. For reviews with photos, we guide the vision language model to first localize the key region in the image, then answer based on the crop and the full image. This improves spatial understanding and makes it easier to tell if a picture actually matches the text, or if it's an ad, irrelevant shot, or stock photo.